everyone. In this video, we're going to look at question number 5. So based on question 2's answer, what is the optimal size of the house to maximize the electricity consumption? So in question number 2, we are exploring the quadratic form, or we also call the second order polynomial regression model. Okay, so we are introducing the x squared to my model. The reason is that we are see a curvature when we are creating a scatter plot. So instead of assuming the x and y, which is the size of the home and the electricity consumption, as a perfect linear relationship, we assume them actually has a curvilinear relationship. So in order to introduce that curvilinear relationship, we are introducing the x squared to my regression model. And quick recall about what we did in the question number 2. Okay, so also in the question number 2, and we're developing our x squared, so which is home size square, and then we run the regression model, and then we are able to achieve this regression output, right? So this is my regression output. Okay, so now the last question here, we are revisiting this question. Instead of answering a forecasting question, we are actually answering a question related to what is the size of the home that will achieve the highest electricity consumption. And so to answer this question, I want to do a quick scatter plot for you guys. Okay, let me insert this scatter plot, show you that curvilinear relationship again. So it's not perfect chart because I need to label my vertical and horizontal axis. I did not do that yet, but I just want to show you here as we're looking at this curvilinear relationship, right? This is the curve versus a straight line. So when you are focused on this curve, and you will notice that there is a peak, which is here. So basically, once the home size reach to here, we are getting the highest electricity consumption. If the home size is bigger than that, the electricity consumption will start to slowly going down. I think one of the reasons might because the larger house, maybe they have better ventilation system, they are better utilize the heat, etc., or have more fan. I don't know what's the reason behind it, but we do see there is a peak. Okay, so therefore, to help you illustrate, every time we are thinking about this kind of curvilinear relationship, like what we saw here, okay? So this is the electricity, and this is the home size. So we are able to see this kind of curve, right? So that's the curvilinear. So that's my trend line. So once you get into the curve, we'll start to slowly going down. And then, so this is my y variable, and then this is my x variable, right? So now the question here is asking when, as we are achieved to this peak, right? So that's the highest electricity consumption we will consume, can relate it to the home size. So what is this corresponding value for the home size, so that we are able to know, hey, once we get into this side, at this size, the electricity consumption is the highest. And then if we build a house larger than that or smaller than that, our electricity consumption will be less than that. So therefore, the question here, we are asking that optimal size house to maximize the electricity consumption. Okay, so how can we answer this question? It's going to go back to our linear regression model again. Okay, remember our regression model is look like this: y equal to b0 plus b1x plus b2x squared, right? So this is the square term we are introduced to capture that curvilinear relationship. So in order to answer this peak, so this is going to relate to your calculus class. So here I show you how to derive the formula, but when you work on your homework on Connect, you can just directly using that formula. But one thing I want to emphasize is that, so the B1, this coefficient, it is the coefficient for x, okay? And the B2 is the coefficient for x squared. So it does not mean B1 is the first B, the B2 is the second. It does not. So the B1 is the B that is the coefficient for x, and B2 is the coefficient to x squared. So that is how we define B1 and B2. Okay, so we take partial derivative of y with respect to x. If this is going to equal to 0, that allows us to get in this dot, and solving this equation will give us the value for x here we're looking for. Okay, again, so if you remember the calculus, that's perfectly fine, so you can walk through with me. Otherwise, you just need to remember what I'm going to show you at the end. Okay, so I take partial derivative of y with respect to x, and I will get, so this is a constant, it will become 0, no longer exists, and I take a partial derivative of this part, we're left to b1, and take partial derivative of this with respect to x, that will give us plus 2, so this what do you call it, the power here will be moved to the front, it will be 2, and then still keep the x, and then the power here will be 2 minus 1, we're left with 1, so it will be b1 plus 2 times b2x, that will give, it has to equal to 0. So solving this equation allow us to identify the value of x that are able to maximize the value of y. Okay, so now we move around b2x and equal to b1. And x will, oh sorry, this is negative, right? Negative. So x will equal to negative b1 divided by 2 times b2. Okay, again, if you remember calculus, and then, or you interested to learn more about calculus, or try to remember what calculus have been taught you, just try to practice here by yourself. Otherwise, the most important one we need is you to remember this equation. So if the question is asked you for the quadratic equation, when x can optimize y. If that's the question, like this one, when what's the value for x can give you the highest value of y, right? So then you just need to apply for this question, this formula. Or if your curvilinear is like this, right? So you have the minimum value, right? So the same, if the question is asked, what is the value of x to allow you to achieve the smallest y? And the same, exactly the same equation, okay? This x equal to negative b1 divided by 2 times b2, that will give you the answer to answer those questions. Now let's apply this formula to this case, okay? Let me go back here. So in question number 2, we already received this regression output. Okay, one thing, again, I want to emphasize is, what is my b1? So b1 does not mean the first b, the coefficient right under the intercept. As you know, this is b0, there's no question. So the b1 is the coefficient in front of x. And the b2 is the coefficient in front of x squared. So here, if you pay attention, so my x is homesize, my x squared is homesize squared, right? So therefore, the b1 here should be the value for homesize. So therefore, I put down here. And my b2 is the coefficient for x squared. So homesize is my x squared. So therefore, this negative 0.000045, that is my b2. Okay, now I can start to solving my x that can answer my last question on this computer skill lectures is what is the home side that will use the maximum amount of the electricity. So applying the formula I just show you on the whiteboard here, right? Negative b1 divided by 2 times b2. So I write down this formula, negative b1 divided by 2 times b2. So I just need to make sure I follow this formula equal to negative b1 divided by parentheses 2 times b2. Okay, as you can see here, I intentionally including that the parentheses. So what happens if you don't have parentheses here is that the order of the calculation here will become b1 divided by b2, and then you get the number and then times b2. So that, as you know, that's incorrect. So the 2 times b2 has to be on your denominator. So therefore, make sure you don't miss that parenthesis. So if you miss that parenthesis, your answer will be totally wrong. Okay, so after I do that, I can push enter. So now here is the answer. So if the house side is 2,665 square feet, that is when we are achieve the highest electricity consumption. So if any of the houses is smaller than that value or larger than that value, their electricity consumption will be smaller than that. And so some student might ask, okay, hey, Dr. J, so if that's the value that achieve the highest electricity consumption, how much electricity they actually consume, right? So what you're gonna do is just equal to y. So that's what you try to estimate y. So since this value become the value you want to use for x, so you just need to type in equal B0 plus this is going to be B1 times x, that's the value for x, and plus your B2 times your x squared, right? So B2 is the coefficient for your x squared. So basically, okay, so here they go. So when the house size is 2,665 square feet, the electricity consumption will be equal to 1,980. But to answer this specific question, what is the optimal size of house to maximize the electricity consumption? And so the answer will be here. So the answer is 2,665. But if the question follow up, the question is asked how much electricity they actually consume. So that answer will be 1,980 kilowatts. So that is how you are able to identify the optimal value of x that can either maximize your y or minimize your y. So the key here is, one, make sure you know the B1 and B2. B1 is the coefficient in front of x, and the B2 is the coefficient in front of x squared. The second is you need to remember this calculation formula. So based on this formula, that will allow you to calculate the x that can optimize your y value. Okay, so good luck with your homework on Connect, and also if you have any questions, feel free to reach out to me.